Everybody, in today's tutorial we will be learning what a VPC is, how do you create and how do you deploy a VPC. So coming to the topic, what is VPC? VPC stands for Virtual Private Cloud, where VPC is a virtual network that will be dedicated to your AWS account. So for example, when you're creating an AWS account, a VPC, that is a virtual private cloud, will be created by default. So you need not, you can actually create a VPC for your business or for your enterprise purposes. It is like a virtual network that will be isolated from the other cloud resources or the other cloud networks which are there. It will be like a separate. You're just isolated from the other thing so that those resources or the cloud will not interfere into yours, nor yours gets interfered into theirs. So basically it is for your privacy and for your security purpose. I can actually give you an example. For example, what happens is when you want to create EC2 instances for your customers or for your business purpose, what you can do is basically you have to create your own VPC. That is, you need to deploy a VPC, and then you're not supposed to use a VPC which is by default, which is not that secure. Or it's better that you create it, and then you can actually attach the instance, that is so-called your EC2 instances, to your VPC for your own personal purposes or for educational purposes. Else, when you're doing or when you have an organization or an enterprise, so it's better that you create your own VPC. So let's move on to how to create or deploy a VPC. We'll have to just move on to the dashboard. Now let's just move into the console. So this is the AWS dashboard, like this is the website of AWS. So first you have to sign into the console using your credentials. So I have to just sign into my account. So here comes the AWS dashboard. So go to services, type VPC. See, you can also see here that is isolated cloud resources. As I've already told you, it will be isolating all your resources. So click on VPC. This is the VPC dashboard. Now you can see that there is one VPC which is already there. Okay, so what happens is this is the default VPC which is created by AWS. So when you're creating an AWS account, as I've already told you, this will create a VPC which is default. Now you have to click on your VPC. See, this is the default VPC which is present. Here you can see that this is the default VPC. Now let's click on create VPC. Now I'll be giving a name tag for my VPC, that is my VPC. So CIDR block will be 10.0.0.0/26. So leave other things by default. Now, if you people don't know how do you calculate the IP addresses using the CIDR block, here I'll be teaching you 10.0.0.0/26. So how do you calculate this? 32 minus 26, which is equal to 6. So 2 to the power of 6. What is 2 to the power of 6? 2 to the power of 6 is nothing but 64. So the total number of IP addresses are 64. Okay. So now so it starts from 10.0.0.0 to 10.0.0.63. So it starts from 0, it ends to 63, where it is nothing but total 64 IP addresses. Okay. So what happens is, in this video we will be dividing this into 4 subnets. That is 4 subnets. We'll look into this in the future. That is a later part of the video. So let's just click on create. So a VPC has been created. That we have finished creating a VPC, we have to create the subnets. See, these are the default subnets. Now we are creating the subnets. So subnet will be subnet name tag first I have to give, that is private A, and then my VPC which we have created. This is the associated CIDR, VPC CIDR. So zone will be availability zone 1. So IPv4 CIDR block 10.0.0.0/28. So we are dividing this into 4. So each will have 16. So 32 minus 28 gives you 16. So it actually makes sense. So create. We have just created one subnet. We are supposed to create 3 more subnets. So it is private B. Subnet is this. Availability zone. Preferred one will be again this only. CIDR. What we are supposed to create is 10.0.0.16/28. As first we started with 0, now we are starting with 16. So 16, whatever the next 16 will be here. So let's click on create. So this is also created. Next we are supposed to create another VPC, that is public VPC. Public A VPC will be my VPC. Availability zone will be east, and then the serial will be 10.0.0.32/28. So now we are supposed to click on create. So this is also created. So you can see public, and then this is a private one. And then you have to create another VPC, that is public B. The VPC is my VPC. The zone which we are creating availability zone 2. Serial 10.0.0.28/28. So now we have to click on create. So close. Now it's that we have created 1, 2, 3, 4. You can see that there are only available IP addresses 11, 11, 11, 11. The 5 IP addresses will be used for the other usage purposes within the network. So 5 IP addresses will not be allocated here. 5 IP addresses will be used for the internal usage purposes. So now we have to create the route tables. Now that we are into the routing tables dashboard, what happens is you can see that these are the routing tables. So when you're creating a VPC, routing table will be created by default. So the VPC name which I've given there will be my VPC. So this is the routing table that is created. So this is the main routing table for that. So let me rename this as public routing table for my convenience. As we have seen that this is a public routing table, I'll be creating another routing table. So that will be private RT stands for the routing table. VPC will be my VPC. Let's click on create. So that will create my this one. Why I have created 2 routing table is that so public routing table will be associated with the public subnets and the private routing table will be associated with my private subnets. As we can see that we have created two routing tables. This is the main one, that is a public one. As you can see, there are no subnet that is explicitly associated. So what we're supposed to do is that we need to explicitly associate some IP addresses or the subnets to the routing tables. So if we don't do that, it will be associated directly with the main routing table, that is the public one, which we don't want it to happen like that. So we have created a private routing table. Now we have to explicitly, now it's that we need to explicitly associate the subnets. So sorry. So let's start with the public one. We need to do the subnet association. As we have seen that as a tool we need to associate, we have to go to subnets. Then you need to click on private, this one. Then route table. You need to edit the route table association. So the route table is of private routing table. Then you have to save it and then close. Select the public one, route table association. Need to select the public route table, save it. Next, select the private one, enable this one, and then the route table association will be public. You have to save it, close. Sorry, for this also public association. For this you need to select the private one, save it, then close it. Now let's go to routing tables. You can see that they're associated with two subnets. Before this was empty and it was not applicable. It was showing 0 subnets. Now it's that they have been associated with two subnets each. That is, we are dividing into four subnets. That is as shown here. So I just forgot to tell something, that is the route table can be associated to multiple subnet, but when one subnet can be associated only with one subnet. So that we have to just keep it in mind. That is, which is very important and very necessary. Now we have finished creating the routing table. So we are coming to internet gateway. What internet gateway does is it acts like a middleman, or which acts like a broker. What it does is it won't let the private routing table or the private request to go out of the internet just directly. It has to pass through the internet gateway, which acts like a medium. So now we have to create an internet gateway, which is a managed service, so you don't have to worry much about it. So I'll be giving a name, that is my internet gateway. So let me just create it. So it's just created. So you can see that the state is detached. So we have to click on this actions. You need to attach to VPC. You're selecting a VPC. By default it shows only my VPC, that is the one VPC which I have created it. Now there can be only one internet gateway for a VPC. So it's that we have finished creating. So you can see that state has changed from detached to attached. We should go to route table. In route table you have to select the public route table. Go to routes. You have to select edit routes. You have to add a route. So it will go to 0.0.0.0 slash this one. Is selecting the target internet gateway, that is my internet gateway. We're just adding the route. Sorry, we're not supposed to add route here. That's it. And then you're saving the route. The route is successfully added. Now we have to select NAT gateway. You have to create a NAT gateway. First, you're first selecting a public one. So let me select my VPC here. I've selected A. Now I have to allocate an elastic IP, create a new elastic IP address, create a NAT gateway. So now we are editing the routing table. Go to the private route table, go to routes. Now it's that you have to edit the route table, add the route 0.0.0.0 slash this one. So it has to go to the NAT gateway. So save the route. As I've already spoken or told you that the private routing table, what happens is whenever a request will be sent from the private, it will not have a public IP address by default. So what it has to do is it has to just pass through a NAT. The NAT will be having a set of IP addresses, that is a set of public IP addresses. So when a request is passed, it goes to the NAT. From the NAT, it will go to the internet and takes just accesses and then gets back. This is how the procedure is, as NAT is nothing but which I've been discussing. Instead, I can give you another example also. Say you have a database, you're running an organization, you have a database where the database wants to install some patches, or it wants to request something from the internet. So it is there in the private subnet. It can't directly send a request and then get back the response. It is not happening. So NAT acts like a middleman or a gateway where it will be taking the request. Sorry, the database will be sending the request to the NAT gateway. The NAT will be sending it to the internet. From the internet, again, it gets back the response. So NAT will be acting like a mediator, and even NAT will be scaling by itself. So you don't have to worry. It is a managed service also. So basically when any request, or there are like too many requests, what happens is it will scale automatically, so you need not worry more about taking care of it. So basically it is very scalable. So now in the subnet region, what you can see is there are only 10 IP addresses in the public A. Why? Because NAT gateway is using one IP address, that is the 11th IP address, which is being taken by the NAT gateway. So that is why it has been reduced by 1 and it shows 10 here. So this is how we can actually create a subnet. You can divide the subnet, create a VPC, create a subnet, dividing the subnet, and then you can create the routing table, the internet gateways, and you can create the NAT. Everything has been shown in this tutorial. Thanks for watching the tutorial. Um, um, you can actually create the VPC based on your need. According to my requirements, I don't have much requirements, so I have just made it very simple, and the size of the subnet is very small. According to your organization and the number of subnets you want, or number of IP addresses you require, you can sizes to whichever size you require. So that's it for today, and thanks for watching my video. Please do subscribe.